Hi folks, this is the first video in a series I'm doing on minimal implementations of DeFi primitives. Today we're going to build a basic staking contract, but over the following weeks I'm going to do a lending and borrowing, stablecoins and other primitives. On screen you'll see a diagram of what we're going to build today. The green rectangle on the left is an externally owned account which is controlled by the user through something like MetaMask or Rabby. Then on the right you have blue rectangle, which is the smart contract or staking contract that has two public functions, stake and unstake. You can probably guess what they do. Stake allows users to stake their ERC20 tokens into the contract, and unstake allows them to withdraw them from the contract. You'll also see an internal get rewards function. That's called when the unstake function is called, and what it does is it mints new ERC20 reward tokens and sends them to or transfers them to the user's EOA. Okay folks, so the first thing we're going to do is set up our Foundry project, origin it to initialize a new Foundry project. Then we're going to install some Open Zeppelin contracts because we're going to import them into our staking contract. I will install them into our lib folder. Got a second. Okay. Then we're going to need to do our remappings so that our contract knows where to look for our Open Zeppelin contracts. Now, remappings. Just going to delete the template files that unpackage the Foundry. Then we're going to just set up our two files. We're going to need a stake and token file. We're also going to need the staking contract. Okay, that's the file setup done. So for our staking token, I've just gone to wizard.openzeppelin.com and use the wizard to configure a staking token. It's not the focus of this video. It's very straightforward. You just need to name your token, your ticker, and the amount. We're just going to mint 1 million. That's our staking token. And what we're gonna do with the staking token is we're gonna deploy it first. Then we're gonna pass the address into the constructor of our staking contract. So we're just going to copy these first two lines rather than rewriting them in our staking contract. New contract, staking. Now we have our contract started. The first thing we're going to do is import the ERC20 contract. ERC20 from Open Zeppelin contracts, interfaces, ERC20. So we're importing this because we're going to need it to interact with tokens, with the staking tokens. Okay, so we're going to need a couple of storage variables. Call this owner. The owner is an address, public, called owner. We're also going to need a staking token. It's going to be ERC20 and public. We're just going to call it staking token. And we're going to need a constructor. And our constructor, the terminal. Our constructor is going to take, one argument. So ERC20, and we call it underscore staking token just to differentiate it from the storage variable. Here we're going to go owner equals message.sender. So we're setting the owner of the contract to message.sender, so the deployer of the contract. And we're going to say that staking token is equal to whatever is passed in here. That is our constructor. we're going to set up two functions, stake and unstake. And both of these are going to take the same parameters into them. So they're going to take the token that we're trying to stake or unstake and the amount that you're trying to stake or unstake. So it's ERC20. Going to be, and we'll just call it token this time. And then we're going to say uint 256 underscore amount. And I'll just copy them. Exact same for unstake. Paste them in there. So for now, we're just going to do a contract, a really basic contract that allows you to stake and unstake your tokens. And this is not very practical. It doesn't, I mean, all you're going to do is stake your tokens in and out of the contract. We're going to build it out, and then we're going to add in rewards and a reward rate afterwards. We start off with a staking function. So there's a design pattern in Solidity called checks, effects, and interactions. So the first thing we're going to do is our checks, and we've passed in a token and we passed in an amount. So we want to check on both of these. We want to check firstly, check that the token is the correct staking token. Then you want to say, check that the user has enough staking token balance to stake. That's our two checks. So first one we're going to say if we say token that's passed in is not equal to staking token. I'm going to say revert with an error underscore not correct staking token. Go. Need to declare error up top. We're going to need events too. So error. That's our first error. So if the token is not equal, if the token that's passed in during stake is not the same as a staking token, throw an error. Next one is going to be to check that the amount that the user has the correct amount. Check if amount is greater than, and we want to say here token. Because it's an ERC20, we've declared the interface. We can say balance of, which is a function on ERC20 tokens. I want to say message.sender, person calling the. So if the amount passed in is greater than the amount that the user has, say revert error user has insufficient balance token. Oh. And error up top. Error. That's our two checks in the staking function. And now what we want to do is we want to accept the tokens into the contract. I want to say token transfer from message.sender, from the message.sender into the contract, which is address. Yes. And you want to say how many of them you're going to accept. There we go. So that's the transfer into the contract. Here. Transfer tokens to contract. Now, all we've done now is transfer the tokens into the contract, but we don't actually have anything to track the balances that the users have actually staked. So what we're going to need a mapping called balances. And we'll do mapping. That's going to be a mapping from the address, so the address of the user, to the amount that they've actually staked. Public balances. And then down here, we're going to update that. So we're going to say balances message.sender equals balances stake again sender plus the amount. This is going to update. So initially when they first stake, the balance is going to be 0. So it's going to be 0 plus whatever amount they put in. But if they try to stake again, then it will be updated with the next. And then, so we've transferred the tokens in, we've updated our balances, and now we just want to emit. Say, emit tokens staked message.sender and amount. Want to emit an event. So we're going to have, we'll copy this. Up. Event. Token staked. That's going to be an address. From. And then we'll do uint. It's uint 256. And it is amount. So amount. There we go. So that's our stake function. Do a couple of checks. Make sure it's the correct token that they're staking. Make sure that you actually have enough of the token to stake. If so, transfer into the contract, update the balances, and then emit an event. So down in our unstake function, the first one is actually going to be the same. We're going to check the token just to be sure they're trying to unstake the correct token. That. And now our second one is that we're going to do kind of the inverse. We're going to check that they have enough of the token staked in the contract to actually unstake. So we're going to say here, what do we say? We're going to say balances. So we're going to check out the balances of message.sender. So that'll check their balance is, and we want to say is, yeah, sorry, less than the amount. Like that, just to be sure. So if the balance is less than the amount, yeah, throw an error. Error. User has insufficient tokens staked. Go again. Top. That's our two checks on unstake. You're going to check if the token is the correct token, and then you're going to make sure that they have enough balance in the contract to actually unstake. What we're going to do is we're going to update our balances, update balances. And we'll do balances, message.sender. As we did in stake, equals balances, message.sender. Minus. Oh, and then what we're going to do is transfer tokens back to user. It's going to be underscore token again. Transfer. Say message.sender amount. Then we do emit event. Emit. That's going to be tokens unstaked this time. Say yeah, message.sender and do tokens unstaked up top. Or events. Event. Address 2 this time. Just going back out to them. And uint 256 amount. Now, okay, so that's our super basic staking contract implemented there. As it stands, it's very impractical. All you can do is stake tokens in and remove tokens. But what we really want to do is we really want to add in a rewards function as well. So there's numerous ways to do this. You could give the contract control over ERC20 tokens. You could, transfer the gas token for the network that is to the contract. What we're going to do though is we're going to make the staking contract an ERC20 contract. So we're going to need to import it here. And the reason we're going to do that is we're going to actually issue the tokens directly from the contract. So ERC20 from Zeppelin as tokens. Say tokens ERC20. ERC. So token. Okay. And then what we're going to say is that the staking contract is an ERC20 contract as well. It's going to give an error straight away. And the reason it's showing all red here now is because because we've made the staking contract an ERC20 contract, we also need to pass parameters to the constructor of the ERC20 contract. So we need to do it down here. We've already passed our staking token into our set our staking token on our constructor, but we also need to say here ERC20 and pass in the parameters there. So we're going to say staking token. Oh, sorry, no, it's going to be rewards token. Rewards token, because this is going to be a token that is implemented, and we just call it, we just say reward. There you go. Fix. What we're doing here is we're importing the ERC20 contract. We're saying that our staking contract is ERC20, and then down here in the constructor, we're saying that the ERC20 here is called rewards token, and the ticker is reward. And what that will allow us to do, it will allow us to mint tokens. Now, one way of doing it is this. So we're going to do function, and we're going to say get rewards. And I'm going to make this an internal function because we're going to call it from another function. We could just do this, mint message.sender 1000. And if we do this here, get rewards, just say get rewards. Now when somebody unstakes, at the end this function is called, and what it will do is it will mint 1000 of our reward token to the caller of the contract, or the caller of the function. The only problem with that is that while this actually gives out rewards, it doesn't have a rate of reward. So if somebody stakes tokens in and unstakes, 5 seconds later, they get 1000. Whereas if somebody stakes in January and then unstakes in December, they'll also get 1000. There's no reward rate. So what we're going to do is, when a user stakes, we're not only going to track the balances of how much they've staked, we're also going to track the time that they staked that. So we're going to say, let's say update timestamps. And for this, we're going to need a mapping up top, almost the same as this mapping. Address, so it's going to be user address. Going to uint 256. That's going to be the timestamp. Public timestamp. Then down here, when somebody stakes, we're going to update this mapping. It's going to be timestamps. Message sender. And what we're going to do is we're just going to set it to block the timestamp each time. It's pretty much going to zero out if somebody stakes again for a second time. It's just going to add, instead of adding the timestamp on, it's just going to reset it to whatever timestamp it is. It's a clearer way of doing it for now. It's not the optimal way to do this. And then what we're going to do is down here, we're going to need a few things. What we're going to do first of all is get amount of seconds that they've staked for, the amount of seconds user has staked for. Then we want to say calculate rewards, and then we want to issue. Okay, so in order to get this, we need to say the current it's the current block.timestamp. It's going to be block.timestamp of this. That's going to be minus timestamp that they staked that. Just sender. Okay. What we'll do is for that, it's going to be uint 256. We call it staking time in seconds. That's the amount of seconds they've staked for. And what we're going to do then is we're going to do a rate. So we're going to calculate. So we'd say the amount of seconds, and we say how much are they going to stake for. We say we get 1 token per second. See, go uint 256. We call it user rewards equals. So that means for every second they staked, they get 1 reward token. Now this could be anything you want. You can change it to 2000. It doesn't really matter. We're going to call it, or just do it as 1 per second. What we'll also do is we will declare, we will just have a variable for it up here. So uint 256 public, and we just call it rewards per second. And we're just gonna set it up here to 1, and because it's set up here, we will just change it to immutable for gas reasons. And it's going to be an immutable storage variable. We'll just bring it back down. And yeah, we're going to change this one here. There. And instead of minting 1,000 each time, we're just going to mint the user rewards. This is a much fairer way of doing it, because it means, going back to our example, if somebody stakes for 15 seconds, they're only going to get 15 reward tokens. But if somebody stakes for, a week, thousands upon thousands of. One last thing we'll do is we'll just import the re-entrancy guard from OpenZeppelin. Import re-entrancy guard from OpenZeppelin. Bills say that here that the staking contract is guard. We're going to say down here on both our stake functions, our public functions, we're going to say non-reentrant. This is just to protect our public functions from reentrancy. Okay, so that's our contract completed. And we have 3 imports, ERC20 for interacting with the staking token. We've ERC20 because our staking contract is an ERC20 contract as well. That allows us to issue rewards in the form of the rewards token. And then we have reentrancy guard just for mitigating against reentrancy. We have our owner address, staking token, rewards per second. We have our balances to track. We have our timestamps to track. We have our errors and our emits or events. We have a constructor where we pass in a staking token and we set our reward token. Then we have two public functions, stake and unstake. There's a couple of checks in each. Then they transfer tokens either in or out, updates the balances and then emits. And then on the unstake function, we also have get rewards, which calculates how long the person staked their tokens for, calculates the rewards based on that, and then issues the rewards to the user. Rather than deploy these contracts to Anvil right now in this video, I'm going to do it in a separate video because it's more to do with Foundry and the Foundry cast command. So it really applies to any of the DeFi primitives that we're going to do. We will use the staking and staking token contracts to do it, but it'll be in its own separate video.